Hi, good morning, one and all. Today we are going to discuss about torque acting on a dipole. Torque acting on a dipole, which is placed in a uniform electric field. So this is today our topic. So first of all, it is basic physical quantities torque. What is meant by torque? Torque is a product of force and perpendicular distance. Right. So here we should consider a uniform electric field. What is uniform electric field? All electric field lines are passing in same direction and its magnitude is also same. So it is called as uniform electric field. So now here, consider a dipole. Consider a dipole. Dipole means what? Last class already we learned. What is done by dipole? Dipole is a set of two equal and opposite charges, minus q and plus q charge, which are separated by a distance is 2a. So it is electric dipole. Right. So which is placed in a uniform electric field and which is makes an angle theta with the field. So it is considered as A and B. The ends of the dipole is considered as AB. So what happens here? Already dipole has two charges. One of the charge is positive, another charge is negative. Already we learned properties of electric field lines. So properties of electric field lines means, so now here any positive charge can be produces electric field in outward direction. Same like that, the path followed by the positive charge is called as electric field line. Path followed by the positive charge is called as electric field. So this is positive charge electric field lines. So same like that here, electric field direction is from left to right side is there. Same like that. Definition of electric field line is the path followed by positive charge is called as electric field line. So that meaning is, so its electric field is along the direction of electric field. Same like that, but it is negative charge. Negative charge is always opposite to the direction of electric field. So if you have some doubt, so actually negative charge direction is always inward direction towards the charge. Electric field lines are towards the negative charge side. So this is actually same like that. It is also same like that only should. So it is electric field lines towards. So this vector can be extended up to here. So this is electric field line outward direction like this. Actually inward direction, but electric field is there. So that's why it is opposite to the direction of electric field. That is very important point. So once again, positive charge direction, electric field direction is always along the field line. Why? Because electric field line definition only, the path followed by positive charge is nothing but electric field line. So that's why electric field direction and positive charge direction same direction. Same like that, but negative means opposite charge. That's why opposite to the direction of electric field. So that only we should understand. So next thing is here, here certain force can be exerted. So that's very important. So why? Because its force is exerted means here this arrow mark, arrow mark once you consider. So observe here, it is left side is there, here right side is there. So these two forces are acting equal and opposite direction, so that's why here couple can be acted. Couple of forces, already we know that electric field formula, force per unit charge. Same like that, F is equal to Q into E. Here also electric field is there. That electric field due to here charge electric field, both are acting certain force. So here that force F is equal to Q into E along the direction of electric field. Same like that, negative charge can be produced certain force, that is F is equal to minus Q into E. So minus Q into E. Why? Because here force is vector. So that's why here it is plus charge plus QE, negative charge negative QE. Right. So this is force, couple of forces are acting on a dipole in a uniform electric field. Due to that, so what happens? So here one small experiment. So for example, it is like a consider dipole. This one, some force like that only consider. So for example, it is a dipole. Pen is considered as a dipole. Here two forces, threads only consider, no? Threads, these threads, two threads only consider. This is acting opposite directions. One direction is this one direction, one thread is acting this direction. Two forces are acting opposite direction, means what happens? Dipole can be changes into or aligned into direction of electric field. So this is the couple of forces acting, then dipole can be rotate, so that is called as torque. So torque means what? Couple of forces are acting on a dipole, due to that dipole can be rotate. So how it is, how to rotate means already we observed here. So it can be aligned parallel to the electric field. So from this is one of the force, this is one force. These two forces between distance is called as perpendicular distance. So it is considered as C. So now perpendicular distance BC. So torque means torque is equal to either force into perpendicular distance. This is original definition of torque. Either force means either this force or this force, but here we should take magnitude only. So now force into perpendicular distance means BC. Force value, magnitude of force means Q into E into BC. BC value don't know. This value BC. The BC value want to find out. So once you observe here, it is makes an angle theta with the electric field. It is theta. It is opposite side. So what theta is suitable for determining BC value? Sin theta. So that's why from ABC triangle, from triangle ABC, sin theta is equal to, sin theta equal to what? Opposite side by hypotenuse. Opposite side is BC, hypotenuse is 2a. So BC is equal to 2a sin theta. So this is perpendicular distance. So next, this value substitute here, 2a sin theta. So here 2a is moved this side, q into 2a is sin theta. So now q into 2a, already we know that dipole moment. So q into 2a is nothing but dipole moment. So now p into e sin theta, this is torque equation. So vector form is written as p cross e. So this is torque vector form equation. right? So now here, when torque is maximum, means if theta equal to 90 degrees, theta equal to 90 means what? Sine 90, 1 into pe, so p into e, so tau is equal to p into e. So when if theta is equal to 0 degrees, tau is equal to what happens? Sine 0, 0, 0. That is tau is minimum. So this is the torque. I hope you understood. Thank you.